Today we're going to overview section 14.2 on prisms. Now to begin this section, I think the first thing we have to do is really cement some vocabulary in our head. Already in chapter 14, the vocabulary has become a little bit demanding and confusing. And so it's going to be very important for us going forward to really master this vocabulary, to know exactly what each of these words mean immediately when we see it, without having to think about it. So first, let's look at this list of purple words, which I have written in the left side of your screen. So the first term is polygon, which we've talked about before, and a polygon is just any closed shape. A series of polygons arranged in three-dimensional space can make a polyhedron, which is any multi-faced, multi-sided object. A prism is two congruent parallel polygons, which are faces, and all the other faces of the shape are parallelograms. So for example, you can have two congruent hexagons, which serve as faces and they're parallel to each other, and all of the other faces of your shape would be parallelograms, and that would be a hexagonal prism. Here depicted, we have a right rectangular prism. So we have two faces, ABCD and EFGH, which are parallel to each other and congruent, meaning they have exactly the same sides and angles. And it's a right rectangular prism. What makes it right is that all of these faces are perpendicular to the parallel faces of the prism. That is to say, AEFB forms a right angle with both ABCD and EFGH. Similarly, side lateral face BFGC forms right angles with ABCD and EFGH. And so this is a right rectangular prism. It's our stereotypical room, where all the sides are congruent and all of the opposite planes or opposite faces are parallel to each other. And this brings us to bases and sides. The bases of a shape are the top and bottom, and the sides are the not top and bottom. Now, bases and sides are important ways of referring to different parts of the shape, but as you can tell, I think intuitively, these things are a matter of perspective. Someone could say, with the shape that I'm looking at, ABCD is a side, and that would make BFGC a base. But bases and sides are a helpful way of referring to prisms and other three-dimensional figures. We have three more vocabulary terms. Total surface area. That is the area of all of the polygons which make up our polyhedron. The lateral surface area is the surface area of just the sides, exempting the bases. So lateral is a Latin word which means side. In football, when you lateral the ball, you have to throw it to your side or behind you. So that can help you remember that lateral surface area is just the sides of your polyhedron or prism that you're working with. Frequently, you will not be asked to find the lateral surface area, but you should pay attention and make sure that the question specifies total surface area or lateral surface area. Our last thing to discuss is volume. So we know that you can measure the length of something in units. We could say this is 1 centimeter. a 1 centimeter line. You can also measure something in square units, where you have a 1 square centimeter box. And you can also measure something in volume. And volume is cubic. So we would call, for example, this shape here, a 1 cubic centimeter box. When I am looking for the volume of a three-dimensional shape, that will tell me how many of these boxes fit inside cubic boxes fit inside of the shape. And so that is what volume is. It's important to know that whether you're dealing with centimeters, square centimeters, or cubic centimeters does matter. To say that something is 30 centimeters is very different than saying something is 30 square centimeters. Is even more different than saying that something is 30 cubic centimeters. Because 30 centimeters could fit into 30 cubic centimeters an infinite number of times, since a line does not take up any space along one of the axes. So make sure you memorize what each of these things are: a polygon, a polyhedron, a right rectangular prism, bases, sides, total surface area, lateral surface area, and volume. With that, let's go on to these example problems. Today's painting is called Along the Tiber with the Castle Sant'Angelo and St. Peter's Basilica by the German painter Rudolf Weigmann. This painting depicts in the center St. Peter's Basilica, and on the right you can see the Castle Sant'Angelo, or the Castle of the Holy Angel, which was once the mausoleum of the Emperor Hadrian, transformed into a large defensive castle. On top stands a bronze statue of St. Michael the Archangel, that is, the angel for which the castle is named. Alright, open your books to page 361, and let's go over problem 14.4. ABCDEFG is a rectangular prism. AB equals 3, BC equals 4, and AE equals 5. Alright, so we have 3 totally different lines on our rectangular prism. Find BF and EH. First, BF. Now, since we know it's a rectangular prism, we know that the bases are congruent rectangles. But since it's a prism, we know that all of the sides are parallelograms. And by definition, parallelograms have parallel sides of the same length. BF is parallel to AE, and therefore they have the same length of 5. EH, similarly, is a parallelogram. EH, similarly, is parallel to AD. And so they have the same length. But you notice we're not given either of their lengths. Instead, we have to realize that AD is also parallel and of the same length as BC. So AD is 4 and EH is 4. Find the volume of ABCDEFGH. So now we're going to have to discover how many of those cubes can fit in here. Now you notice we haven't been given any formula for figuring this out. Instead, we are just going to figure out volume on our own. So we know that from F to G is 4, so we can fit 4 cubes across. And we know that from G to C is 5. So we can get 5 cubes up. And then we know that from E to F is 3. So we can fit 3 cubes deep. There we go. 4 across, 3 deep, 5 tall. That's how many cubes we can get. So if we just focus on tall and across, and not deep at all, we would get 20 cubes. 5 times 4 is 20 cubes. And then how many deep would we get? We'd get 20 cubes 3 times. We'd stack those 3 cubes in 3 deep. So that would be 20 times 3, which is 60. So our volume is found by taking the height times the depth times the length. 5 times 3 times 4 is 60. Next, find the total surface area. So we're going to first ask, how many faces do we have to deal with in the total surface area? How many is it? On this figure, it's 6. So we have 6 rectangles to discover the surface area of. Our first rectangle is AEFB, which is 5 times 3. AEFB and ABCD equals 3 times 4. And BFGC is 4 times 5. And we multiply those all by 2 and add them together, since for each of these planes there's one that's exactly like it. 30 plus 24 plus 40 is 94. So that was not so bad. We just had to use a bunch of addition, basic arithmetic. Okay. Next, find AC. Now AC, we know that this is a right angle. And we know that AB is 3 and BC is 4. You could use the Pythagorean theorem, or if you already have it memorized, that 3 and 4, the hypotenuse is going to be 5. AC equals 5. So the diagonal of that face, ABCD, is 5. Okay. What kind of triangle is ACG? This is a good one. ACG. Now this one's a little tricky, but hopefully you just refer it to the room that you're in, and it makes a lot more sense. A line that's diagonal across the ceiling goes down the wall along the corner, and then connects back to that first corner on the ceiling. It's still going to be a right triangle, albeit along a very interesting plane. And AC, we've already found, is 5. CG, we already know, is 5 as well. This gives us a 45, 45, 90 triangle. What is AG? Well, we can use the Pythagorean theorem for ACG. 5 root 2 plus 5 root 2. And you'll get 50. Square root of 50, and the square root of 50 is 5 square root 2 equals AG. So that's problem 14.4. It's not so bad. For 14.5, we're just going to investigate some properties of cubes. And we're all used to cubes because we've played with dice before. A cube is a special rectangular prism in which all edges have the same length. Find the formula for the volume of a cube with side length s. So what is the formula for the volume of a cube? We can figure that out using what we did to find the volume of problem 14.4. We know that it was some measure across, some measure deep, and some measure tall, and we multiplied these by each other. In this case, we know that that measure is the same in each direction. That's what makes a cube a cube. It's the same measure deep, across, and tall. And we'll call this measure S. So what's the area of a cube? The side length of S? It's S times S times S. Also stated, S cubed. Find the formula for the total surface area of a cube with side length S. Once again, we're just going to abstract from the previous problem. S squared plus S squared plus S squared all times 2 equals 3S squared times 2 equals 6S squared. 6 sides, S squared. And lastly, find the formula for the length of SY in the diagram, given that the figure is a cube with the side length of S. Now this is a good one. What is SY? Well, SY, let's take SUY and have a triangle. Okay. So on this triangle, we know that UY is S. What's SU? Well, we have a 45, 45, 90 triangle. SU is going to be S square root of 2. And we still have a right triangle in SUY. So we can find the hypotenuse using the Pythagorean theorem. S squared plus S square root of 2 squared equals SY. And let's simplify this and we might find something interesting. S squared is S squared plus S squared times square root of 2 times square root of 2, which is 2. And that will reduce down to 3S squared. We can pull out the S, and we will get S square root of 3 equals SY. So that's pretty cool. Set in stone, and we know that the diagonal through a cubic room, or through any cube, is the side times the square root of 3. Okay, for 14.6, just a continuation of working with the same cube. What geometric shape is SXYV? SXYV. Now this might be hard to symbolize, and if you're like me, you're starting to experience some severe, vertigo, where it's becoming very hard to even look at this cube anymore and know what's going on. So, an easy way to figure out what's going on with these three-dimensional shapes when the drawings are a little less than clear, SXYV, is to draw the shape for yourself and then label what the sides are in terms of their length. So we know that SX is s squared root of 2, and vy is s squared root of 2, and xy is s, and sv is s. Do we know the angles of any of these? Yes, we know that sxy is still a right angle. Now you might be tempted to say it's a parallelogram because from our vantage point it looks like a parallelogram. But it's important to remember that we're seeing two planes intersect, and those two planes are intersecting at right angles. So Sx is intersecting the plane, say, xtuv at a right angle, and thus this is a rectangular shape. What is the area of our shape if SV equals 4? Well, if SV is 4, then Sx is 4 root 2. And so we'd multiply those together and get 16 root 2. Our last problem is 14.7. And so this is another prism, but you'll notice that what makes it a prism are two congruent hexagons as the top base and bottom base, as opposed to rectangles or squares like we've been dealing with in the previous problems. We are told that the length of 4 on the base for each side, so this is a regular hexagon, where AB equals BC equals CD, and it has a height of 8 units. Now you might be wondering why they don't use a lot of different letters from the alphabet. Instead they use A, B, C, D, E, F twice. So one thing you can do in mathematical notation is you can, instead of writing a new thing, you can indicate that it's similar to a previous version of the same variable by putting that apostrophe. That apostrophe mark is read as the word prime. So on the bottom we have A, on the top we have A prime. On the bottom we have B, on the top we have B prime. And I've even color-coded them so that you can see the difference, see that they are different clearly. And that's helpful to use the same letter twice because it indicates to us that this point is the equivalent point on the congruent shape. Okay, our first question is find the lateral surface area. So we need to find the surface area of just these 6 faces, excluding the bases. The key word in our problem is that this is a right regular hexagon, and that means that these faces are forming right angles with the bases. So since the sides are forming right angles with the bases, we know that each of these sides is going to be a rectangle, and that's extremely helpful to know. And since each one is 4 by 8, each one has 32 square units. And 32 times 6 would be some larger number, which would be the lateral surface area. So let's write that out. I'll say AB equals 4 times 8, and then the lateral surface area is 6 sides, 6 congruent sides, and so the lateral surface area is 192 square units. For the total surface area of the prism, I'm going to have to add in those 2 hexagons. So I'm going to need to find out how to find the area of a hexagon. Now this is great because hexagons are actually not too bad to work with. Let me draw a regular hexagon for you. It's not going to be perfect. So you might remember that a hexagon is made up of 6 equilateral triangles. See if that helps you, and see if you can solve the rest then on your own. So you should realize the area of each of these little triangles is 4 times 2 square root of 3 over 2, which means that each of these is 4 root 3. And there's 6 of them, so 4 root 3 times 6 is 24 root 3. There's 2 hexagons for our bases on our figure, so that's a total of 48 root 3. And if we add that to our lateral surface area, we have our answer. 192 plus 48 root 3 square units makes our total surface area. Thanks for joining me in 14.2 Prisms. With all of that, you should easily be able to complete this homework. Take care.